Hello, Mr. Daldis here with your reading for Chapter 13, Section 5, The Scientific Revolution. The Renaissance and the Reformation facilitated the breakdown of the medieval worldview. In the 1500s, a profound shift in the scientific thinking brought about the final break with Europe's medieval past. Called the Scientific Revolution, this movement pointed toward a future shaped by a new way of thinking about the physical universe. At the heart of the scientific revolution was the assumption that mathematical laws govern nature and the universe. The physical world, therefore, could be known, managed, and shaped by people, changing views of the universe. Until the mid 1500s, Europeans' views of the universe was shaped by the theories of ancient writers Ptolemy and Aristotle. More than 1,000 years before the Renaissance, they had taught that the Earth was the center of the universe. Not only did this view seem to agree with common sense, it was accepted by the church. In the 1500s and 1600s, however, people began to question this view. Copernicus challenges ancient astronomy. In 1543, Polish scholar Nicholas Copernicus published On the Revolutions of the Heavenly Spheres. In it, he proposed a heliocentric, or sun centered, model of the universe. The sun, he said, stands at the center of the universe. Earth is just one of several planets that revolve around the sun. Most experts rejected this revolutionary theory. In Europe, at the time, all scientific knowledge and many religious teachings were based on the arguments developed by classical thinkers. If Ptolemy's reasonings about the planets was wrong, people believed, then the whole system of human knowledge might be called into question. But in the late 1500s, the Danish astronomer Tycho Brahe provided evidence that supported Copernicus's theory. Brahe set up an astronomical observatory. Every night for years, he carefully observed the sky, accumulating data about the movement of the heavenly bodies. After Brahe's death, his assistant, the brilliant German astronomer and mathematician Johann Kepler, used Brahe's data to calculate the orbits of the planets revolving around the sun. His calculations supported Copernicus's heliocentric view. At the same time, however, they showed that each planet does not move in a perfect circle, as both Ptolemy and Copernicus believed, but in an oval-shaped orbit called an ellipse. Galileo's heresies. Scientists from many different lands built the foundations laid by Copernicus and Kepler. In Italy, Galileo Galilei assembled an astronomical telescope. As you have read, he observed that the 4 moons of Jupiter move slowly around the planet. Exactly, he realized, the way Copernicus said that Earth moves around the sun. Galileo's discoveries caused an uproar. Other scholars attacked him because his observations contradicted ancient views about the world. The church condemned him because his ideas challenged the Christian teachings that the heavens were fixed in position to Earth and perfect. In 1633, Galileo was tried before the Inquisition, and for the rest of his life he was kept under house arrest. Threatened with death unless he withdrew his heresies, Galileo agreed to state publicly in court that Earth stands motionless at the center of the universe. Legend has it that he left the court, he muttered, and yet it moves. Checkpoint. Why was Copernicus's theory seen as radical? A new scientific method. Despite the opposition of the church, by the early 1600s, a new approach to science had emerged based on observation and experimentation. During the Renaissance, the works of the ancient Greek philosopher Plato were rediscovered. Plato taught that man should look beyond simple appearances to learn nature's truths. He believed that mathematics, one of the greatest human achievements, was the key to learning these truths. His teachings were rediscovered by Renaissance scientists and helped shape people's view of the physical world. Bacon and Descartes, revolutionary thinkers. The new scientific method was really a revolution in thought. 2 giants of this revolution were Englishman Francis Bacon and the Frenchman René Descartes. Each devoted himself to understanding how truth is determined. Both Bacon and Descartes, writing in the early 1600s, rejected Aristotle's scientific assumptions. They also challenged the scholarly traditions of the medieval universities that sought to make the physical world fit in with the teachings of the church. Both argued that truth is not known at the beginning of the inquiry, but at the end, after a long process of investigation. Bacon and Descartes differed in their methods, however. Bacon stressed experimentation and observation. He wanted science to make life better for people by leading to practical technologies. Descartes emphasized human reasoning as the best road to understanding. In his Discourse on Method, written in 1637, he explains how he decided to discard all traditional authorities and search for provable knowledge. Left only with doubt, he concluded that doubt was the only thing that he could not question, and that in order to doubt, he had to exist as a rational, thinking being. Therefore, he made his famous statement, "I think, therefore I am." A step-by-step process. Over time, a step-by-step process of discovery evolved that became known as the scientific method. The scientific method required scientists to collect and accurately measure data. To explain the data, scientists used reasoning to propose a logical hypothesis or possible explanation. They then tested the hypothesis with further observation or experimentation. Mathematical calculations were used to convert the observations and experiments into scientific laws. After reaching a conclusion, scientists repeated their work at least once, and usually many times, to confirm and refine their hypothesis or formulate better ones. Checkpoint. How did Bacon and Descartes each approach new scientific method? Breakthroughs in medicine and chemistry. The 1500s and 1600s saw dramatic changes in many branches of science, especially medicine and chemistry. The rapid changes in science and technology that began in this period still continue to this day. Exploring the human body. Medieval physicians relied on the works of the ancient physician Galen. Galen, however, had made many errors, in part because he had limited knowledge of human anatomy. During the Renaissance, physicians made new efforts to study the human body. In 1543, Andreas Vesalius published On the Structure of the Human Body, the first accurate and detailed study of human anatomy. Vesalius used whatever means he could to increase his knowledge of anatomy. He used friendships with people of influence to get invitations to autopsies. He also autopsied bodies that he himself obtained, counting on friends in the local government to look the other way. In the 1540s, French physician Ambroise Paré developed a new and more effective ointment for preventing infection. He also developed new surgical techniques, introduced the use of artificial limbs, and invented several scientific instruments. Then in the early 1600s, William Harvey, an English scholar, described the circulation of blood for the first time. He showed how the heart serves as a pump to force blood through veins and arteries. Later in the century, the Dutch inventor Anton van Leeuwenhoek perfected the microscope and became the first human to see cells and microorganisms. These pioneering scientists opened the way for further discoveries. Transforming chemistry. The branch of science now called chemistry was a medieval science called alchemy. Alchemists believed that any substance could be transformed into another substance, and many of them tried unsuccessfully to turn ordinary metals into gold. With the advances of the scientific revolution, the experiments of alchemists were abandoned. However, some of their practices, especially the manipulation of metals and acids, set the stage for modern chemistry. In the 1600s, English chemist Robert Boyle refined the alchemist's view of chemicals as basic building blocks. He explained all matter as being composed of tiny particles that behave in knowable ways. Boyle distinguished between individual elements and chemical compounds and explained the effect of temperature and pressure on gases. Boyle's work opened the way to modern chemical analysis of the composition of matter. Checkpoint. How did Boyle transform the science of chemistry? Isaac Newton links the sciences. As a student in England, Isaac Newton devoured the works of leading scientists of his day. By age 24, he had formed a brilliant theory to explain why the planets moved as they did. According to one story, Newton saw an apple fall from a tree. He wondered whether the force that pulled the apple to Earth might not also control the movements of the planets. In the next 20 years, Newton perfected his theory. Using mathematics, he showed that a single force keeps the planets in their orbits around the sun. He called this force gravity. In 1687, Newton published a book explaining the law of gravity and other works of the universe. Nature, argued Newton, follows uniform laws. All motion in the universe can be measured and described mathematically. To many, Newton's work seemed like a link the sciences just to many, Newton's work seemed to link the sciences just as gravity itself bound the universe together. For more than 200 years, Newton's laws held fast. In the early 1900s, startling new theories of the universe called some of his ideas into question. Yet his laws of motion and mechanics continued to have many practical uses. For example, calculus, a branch of mathematics particularly developed by Newton and used to explain his laws, is still applied today. Checkpoint. How did Newton use observations of nature to explain the movements of the planets? That's it for Section 5. Thanks for listening. Have a great day.